Welcome to ACI, the Network Made Simple learning series. In this video, we will cover Module 5, Extending the Fabric, Chapter 2, ACI Multipod. In the previous chapter, we covered the ACI Anywhere concept and the different options we have to extend our fabrics within a single site or across multiple sites. Now, we will dig deeper into single-site extension with Multipod, showing you a few extra details as well as its configuration steps. You may remember that as of ACI 5.23, we have two connectivity options for Multipod. One, back-to-back, which simply requires you to physically connect the spines on each pod so that APIC automates MPBGP, EVP, and VXlan and OSPF on top of such physical connection. Remember, this option is only suitable for 2 pods. Therefore, if you need more than 2 and up to 12 pods, you may need to go with the second option, which is using an interpod network or IPN. This type of setup requires you to cable the spine nodes on each pod to an external routed network, which will serve as our multipod underlay, and then APIC will automate on top of it the configuration of MPBGP, EVP, and VXlan across pods. This option has been around for a while now. However, it is important to mention that as of ACI 5.23, the IPN first hop device to which each spine is connected to can now run either OSPF as a routing protocol, which was the only option before, or BGP, which is now also supported. The back-to-back multipod ACI option is very straightforward and fully automated by APIC. Therefore, in this chapter, I will only focus on the IPN option, which requires an external network. In this example, I have data centers in Miami and Fort Lauderdale, which are 2 cities that are very close to each other, and I have a round-trip time of less than 50 milliseconds. I want to extend layer 2 between them without paying for expensive data center interconnect technologies, while managing both data centers as one. Therefore, Multipod seems like a great fit. I already have ACI running in Miami. That will be my pod 1. I will start by physically connecting my spine nodes to an external routing device which will be part of my IPN, and which should connect to the second pod or to a routed network that could take me to it. There is no need to connect every spine node to the IPN. However, please consider redundancy in your designs for production environments. As mentioned before, we will need an underlay between pods to build our VXLAN tunnel on top of it. Therefore, we will run either OSPF or BGP on the IPN first hop links, which will be transported over VLAN 4. Why VLAN 4? Well, because APIC automatically configures the underlay protocol on the spines using such VLAN, and we must make the configuration match on the IPN side as well so that OSPF or BGP peering succeeds. That's the reason why my first hop IPN device will need to support sub-interfaces. APIC will configure both the physical and logical network configuration for your spines. If we take a step back and think about it for a second, this is basically an L3 out on the spine nodes. But instead of doing it manually, the ACI Multipod wizard will help us automate the corresponding access policies and L3 outs. We need this underlay configuration so that the other pods can learn about the spine IP addresses, loopbacks, VTEP addresses, and many others. At this point, we would be set with Miami. However, APIC can only automate what it can control, and the IPN first hop is an external device. So make sure you manually configure it as I will show you next, and include the routing protocol you choose, running on VLAN 4, and an IP address on each interface, considering a subnet for each point-to-point link like displayed in this case. Once pod 1 is ready, we would need to do the same in the second pod, cabling the spines on that side to an IPN first hop device as well, making sure that those devices have the corresponding routing protocols and IP addresses configured as well. In the case of pod 2, your spines will have an empty configuration and will not be associated to an APIC jet. So, how will they be discovered by my APIC cluster? Well, if you remember, the first thing a switch does when it boots up is send a DHCP request, trying to get an IP from the TEP pool, right? So the same process will follow in a multi-pod environment. However, we must have a special consideration for this to work. Since pods are separated by a routed network, we must configure Dhcp Relay on the IPN interface facing your spine nodes. Such Dhcp Relay configuration will point out to the APIC's internal IP addresses, which are based on your Pod 1 TEP pool. You can check the value of those IP addresses by going to your APIC console and then issuing the command show controller, or you can also see it by accessing the GUI in the controller section. Once the request makes it to the APIC, both the spines will show up as newly discovered nodes, and you will simply have to follow the process you already know, assigning a name and a switch ID. The only difference here is that we will need a dedicated TEP pool for each pod you create, and that you will assign the right pod number whenever the discovery process occurs. That's it. After accepting pod 2 spine nodes in the fabric, ACI will take care of the rest, configuring the underlay and overlay for pod 2 nodes, as well as extending layer 2 automatically between pods while maintaining visibility under the same APIC cluster. This means you would now be able to move workloads between pods without restrictions, and that you will automatically extend the same Anycast gateways you configure on your bridge domains across multiple pods now. But you may be wondering, how is the endpoint information such as IPs and MAC addresses exchanged between pods? Well, that is why we automate MPPGP EVPN VXlan between pods. Each multipod spine will know about other pods' endpoints by pointing out to the corresponding spine VTEP IP address as the next hop. And what happens if a spine or a leaf node does not know about an endpoint and need to perform ARP flooding or hardware proxy, for example, as covered in Module 3, Episode 2? Well, that is exactly the reason why multipod needs multicast enabled over the IPN. We need to extend the GPO, which is the multicast block used for each bridge domain, across both pods in this case, and allow the spines to perform ARP cleaning when needed. In order to comply with this requirement, we need to make sure each interface along the IPN has PIM sparse mode configured and that PIM biter is enabled configuring a rendezvous point somewhere in your IPN. Make sure you include the GPO multicast range, usually the 225000/8 block, as well as the 239.255.255.240 address group, which is used by ACI for ARP cleaning, and you should be fine. Feeling a little lost with all this multicast madness? No worries, I will show you how to configure this in your IPN in just a few seconds. Please also remember to consider the extra 50 bytes based on your payload's MTU to accommodate VXlan and cap along the way. As you finish your multipod configuration, you can leave all APICs in one pod or distribute them across your pods for high availability purposes. If you decide to go with the latter, you may want to add standby APICs to avoid loss of quorum if your IPN fails. As of the recording of this video, a multipod site supports up to 500 leaf switches controlled by a single APIC cluster. Let's now move on to the scenario we will configure in this chapter. I will configure a couple of ACI pods, Miami and Fort Lauderdale, and we will perform vMotion between both of them with minimum network disruption and without changing any EPGs or contracts, leveraging Multipod's VXlan as my layer 2 network extension. In order to configure multipod, we will perform these 3 simple steps. 1. We will set up the IPN. 2. We will run the ACI multipod wizard. And 3. We will perform vMotion between pods to test communication still prevails without any changes. Are you ready? Let's get started with step 1 then, verifying the setup of my IPN. In my case, I have a lab environment with a single Nexus 9000 switch called N9K IPN Site 1, which is running NXOS in standalone mode and which is behaving as my IPN between pods. I have enabled PIM, interface VLAN, DHCP, and OSPF features on it. Since I could be using this switch for other purposes, I have also created a dedicated VRF for my IPN traffic, which I called mSite. Then, I have multiple interfaces, each facing a different spine on each pod. In this case, I have 4 total. 151 and 153 are facing the spines on pod 1, and 152 and 154 are facing the spines on pod 2. Since it seems I have a lot of IP addresses available, each interface belongs to a different /24 subnet, but you can definitely use smaller masks if needed. Let's now take a look at one of the interfaces connecting to one of the spines on pod 1, for example 153. We can see that the physical interface only has its MTU set to 9000 and its VRF association. From there, everything else is created on the sub-interface using Vlan 4, which has an IP address, OSPF enabled, and PIM sparse mode. If we now take a look at one of the interfaces connected to one of the spines on pod 2 this time, we can see the configuration is pretty much the same, except for its IP address, which is obviously different, and an IP Dhcp Relay configuration which points out to the APIC internal IPs. If we now take a look at the routing protocols overall, OSPF is running globally within my VRF, and my Nexus 9000 IPN switch is also behaving as a rendezvous point, or RP, for the GPO multicast block and the ARP cleaning group as mentioned before. That 13.1.1.1 IP address you see there for the rendezvous point is just a loopback address I have configured locally, as you can now see. And that's basically it for your IPN. If you have more than one switch along your IPN, just make sure you have PIM enabled along the way, as well as the MTU consistently configured. If you have a different routing protocol running in between first hop IPN devices on each pod, just redistribute the chosen multipod protocol, whether OSPF or BGP, into that intermediate protocol to maintain route learning between pods, and you should be fine. We are now ready to run the multipod wizard on APIC. So, join me in part 2 of this video and let's finish our configuration.